Hello, Year 4, and welcome to my second science lesson on the science of sound. So last week we learned about what a sound is. This week we're learning about how sound travels, and I want you to have a look at this picture behind me, because this will give you a bit of a clue about how sound travels. So I will share my screen. The LO is, I understand how sound travels to the ear. So let's get started. Let's just quickly recap. Last week we looked at what a sound is. So all sounds are made by a what? Can you try and answer that? And the answer was a vibration. So the most obvious example is a guitar string. A vibration is a very, very quick movement up and down. So all sounds are caused by something vibrating. And then we did the experiment. We made telephones out of cups and string. And the way that the sound travels from one cup to the other is that the string, when it was tight, would vibrate, and it would send the voice along the string through a vibration into the cup and then into the ear of the other person. So that was what we did last week. So today I want you to think about, how does sound travel to the ear? So just stop and think about, how do you think sound actually gets there? We don't see anything. So if I'm talking and you're on the other side of the room, how is that sound getting from my mouth to your ear? Well, the first thing you need to know is that air is made of invisible things called particles. So air isn't just empty. So the room might look empty to you in the air, but actually it's full of millions and millions of tiny invisible things called particles. You might not be able to see them, but you can feel them. The way to feel them is to take your hand and just swish it back and forth. And do that right now. And you can actually feel something, can't you? And that feeling, it feels like air hitting it or wind hitting it. It's just particles hitting your hand. Okay. So particles are in the air, and they're very, very important for the way for how sound travels. So when a sound is made, and the sound is coming out of the speaker here, the vibration makes the air particles vibrate. These particles then vibrate the particles next to them, and so on until the sound wave reaches the ear. So we've got here a speaker. Let's say there's some music coming out of here. That piece of rubber is vibrating very quickly, and the air particles that are right next to that speaker start to vibrate. They start to vibrate and jiggle around. And when they do that, they knock the particles next to them and make them vibrate in that way. And they knock those ones, and they knock those ones. And it sort of, they just keep pushing each other across and vibrating. And it creates something called a sound wave. Okay, and this information gets carried forward until it reaches the ear. And then it goes into the ear, but we'll be studying that later on. So I won't tell you exactly what happens in the ear. But the particles aren't really, they're moving back and forward, but these particles here, they're not flying into the ear. They stay more or less where they are. It's just that they vibrate, they move back and forward in a special pattern, and they knock the ones next to them and knock the ones next to them like that. So another way to visualize it, and this will be in the video that I've posted up with the on the class story and with the work. This lady here, she's banging this sort of skin here, and these balls are all hanging from bits of string, you can't really see them. So when she hits that skin knocks that ball, which knocks that one, which knocks that one, which knocks that one. So it's sending a wave of energy across the line of balls. And so that information will be sent to that last one there. So that's another way of just picturing it. Okay. So it's sending a wave of energy across the room towards the ear of the person listening. And that is how sound travels. Now, it wouldn't just be a line of balls like this. It would be millions and millions of them all dotted around that area. But this line of them just shows you what's happening. Next, so sound travels as a wave in all directions. So we've got to think about what we mean by a wave. So we think of waves in water, don't we? So here we've got a stone being dropped in the water, and it sends out a wave of energy in all directions, doesn't it? So when the stone does that, the water doesn't really move. That wave isn't water moving from there to there. It's just energy that's traveling through the water and making that wave shape. So it's the energy created by the stone dropping in there, and it sends out this wave of energy in all directions. And that's what's happening with sound as well. You just can't see it. But thinking of a wave in water is a nice way to picture it. And here we've got sound waves pulsing towards somebody's ear. So remember, they travel in all directions. So we've got here a police car with its siren blaring. And if you're standing here, you can hear it. And if you're standing there, you can hear it. And if you're standing up there on that building or in the air, you'll be able to hear it there, because sound travels in all directions. It doesn't just go in one way, does it? Okay. But it does bounce around. So it might bounce off these buildings. It might bounce in different directions. That's how you get echoes. It will go into the ground as well, but it won't travel as far because eventually the solidity of the ground would start to soak up the sound. But it travels in all directions. Think of it as like a bubble that's just growing. It just goes out and out and out. So let's have a think about this. There is no sound in space. So I want you to think to yourself, why does sound not travel through space? So pause the video here and have a think. Okay, and now you've unpaused it. Well, the answer, the reason why sound can't travel through space is because space is a vacuum. Now, a vacuum is just means when there are no air particles. Okay, so a vacuum, you can create them on Earth where you suck all the air out of a container and there's just empty space. And if there's completely empty space, then if there are no air particles, then the sound waves can't be created because there are no particles to knock into each other and vibrate. So remarkably, you could be in space shouting at someone next to you through your spacesuit, and they wouldn't be able to hear you. So I've got here a picture of an astronaut with trying to play the drums in space, which isn't really working. His drums are all floating away. But that drummer could be right next to that astronaut there. And this one, they wouldn't hear a thing because in space, there are no air particles for that sound to travel through. So you could be the loudest sound right by your ear and you wouldn't hear anything because space is a vacuum. Next, true or false? Let's have a think about this. Sound can travel through solids and water. So I want you to pause the video here and just have a think. Do you think that's true or false? Sound can travel through solids and water. Well, the answer is true. So sound can travel through solids and water. So for example, we've got here a noisy neighbor, this old lady, she likes to play electric guitar, and you'll all have experienced noisy neighbors at some point in your lives, won't you? You've heard their music, shouting, dog barking, baby crying. So you know that sound can travel through walls. So therefore, sound can travel through solids. Now, it might muffle the sound, but actually, it travels quite quickly through solids. You'd be surprised to know because as we've learned from the previous topic in science, the particles are all more tightly packed. And that means that sound can travel quicker through them. Okay, so sound can travel through solids. It can also travel through water. In fact, it actually travels more quickly through water, again, because those particles are more tightly packed. So sound travels through water 5 times faster than it does through air, which is incredible. And did you know that whales can communicate with each other across entire oceans and for hundreds of miles? So they communicate with something called sonar. They make clicks and wails and sound, sort of high-pitched screeching sounds, and they flap their fins they bash it on the water to communicate with other whales who can honestly be hundreds of miles away. So it actually travels incredibly well through water, even though it might sound a bit muffled to our ears. Okay, so whales can communicate for hundreds of miles. Right, next, let's have a think about lightning and thunder. So why do you normally hear the thunder after the lightning? And this has got something to do with sound and the way sound travels. So just pause the video here and just discuss with someone with you or have a think about why when you see lightning, you hear the thunder later. Okay, well, the answer is because light travels much quicker than sound. So lightning and thunder actually happen at the same time. So lightning is this flash of this burst of energy, of electrical energy. And if you were ever to be unlucky to be, and this has happened to me before, where lightning struck my back garden when I was a kid, I was a child, and it struck in the garden. I was there right then. It didn't sound like thunder. It sounded just like one enormously loud bang. So what you're hearing when you hear thunder is that bang sort of rumbling across, because normally we're not very close to lightning when it happens, unless you're very unlucky. And what happens is that, so let's say there's a lightning storm going on 5 miles away. You see the lightning straight away because light travels incredibly quickly. You see it almost instantly, whereas the sound takes longer to travel. So the lightning happens, but the sound takes a while to get to you. And then a few seconds later, you hear the thunder. So that's why the thunder comes after the lightning. They actually come together. It's just the light gets there much quicker than the sound. So let's have a look at this. How fast does sound travel? Well, it does travel pretty quickly. It travels at 343 meters per second. So every second it travels 343 meters, which sounds pretty quick, doesn't it? Okay, but and that's 770 miles per hour. So faster than any car that we've got, faster than trains, but it's nowhere near as quick as light. Oh, and that would be, so if you to make an enormously loud sound, it would take 67 hours to travel all the way around the world and back. So pretty quick. but not the quickest thing. Light, on the other hand, travels at 186,000 miles per second. So as far as we're concerned, it happens just instantly. And that would be, so a beam of light would travel 7.5 times around the Earth in 1 second. So far, far quicker. So that explains why we see the lightning so much quicker than we hear the thunder. Something else to think about is how can we tell how far away lightning is? There's a little trick. You might have seen people do it, but often people get it wrong. They count the seconds and then think that means how many miles. So if you're in a lightning storm, or you can hear some thunder and you want to know how far away that storm is, this is what you need to do. So first, you wait for some lightning. And then as soon as you hear the lightning, you start counting. And you count how many seconds from when you see the lightning to when you hear the thunder. So you see the lightning, you start counting 1, 2, 3, 4, 5, and you keep counting until the thunder, you hear the thunder, and then you stop counting. And then you take that number and you divide it by 5. And this tells you how many miles away the lightning is. So, for example, if you had to count 15 seconds, you do 15 divided by 5, will give you the answer of 3 miles away. If it took the thunder 5 seconds to arrive after the lightning, you divide that by 5, that would tell you it's 1 mile away. And that's because sound takes about 5 seconds to travel 1 mile. So it's a really useful thing for finding out how far away a lightning storm is. Something else to do with speed of sound. So you might have, if you've been lucky enough to see a sort of fighter jet flying incredibly fast overhead, which I have seen a few times before in this country, some of these airplanes can actually travel faster than the speed of sound, which is called supersonic flight. And something very strange happens. This happened to me before. I was near an airbase in Yorkshire. I think it's called Catterick, or was it? It was near there anyway. I saw this aeroplane flying over and it whizzed over me quite low. And I thought, that's a very quiet airplane. It didn't make any sound at all. And then a few seconds later, I heard this vroom. And that's because the plane was traveling faster than the speed of sound, which means that the plane got there before the sound. It was making this noise, but the sound it was making was getting left behind. And the plane got there before the sound, which is a very weird sensation to see something before you hear it. But yeah, that's an example of something traveling faster than the speed of sound. What else have we got here? So why do you think things further away sound quieter? So someone standing here will hear this siren much louder than someone standing here. I'd like to have a think about why this might be. Well, the answer is that the sound has to cover a greater and greater area and it loses energy. So as the sound travels further and further out, it's only got the energy of that one thing, so that siren blaring. And bit by bit, it just has to try and cover a wider and wider area. So eventually that energy just sort of peters out. So the further away you are, the less energy has reached you because it hits other things. It has to spread out in a larger and larger bubble. It hits buildings and trees and various other things, and some of it bounces away and it just loses its energy eventually. Right. So today's task, that's all the information on the speed of sound, on how sound travels. So today's task, I'd like to complete the forms quiz. So just click on the link in your portfolio and there'll be some questions to answer. They're quite tricky questions, so you'll need to make sure you've watched this video carefully. Right, I will stop there. Thanks for listening. Bye-bye.